Storms, how do the storms happen in a flat Earth? That's a good question. Yeah. Do you guys actually believe in flat Earth?
I've been asking globe proof, not questions.
Yeah, but just to end that, the storms move above the flat Earth. So now, do you have any proof of the globe?
Well, I have a few.
Okay, start with your best one.
The best? The most, well, I'm going to start with the most obvious one. When you look through the horizon and you see, let's say you have a lot of time. You have, like this Discord VC, nobody's talking, you have nothing to do, and you are on Discord VC, and you are sitting near the ocean. And then you are looking to the horizon, and then you see a boat going by. And after some time, the boat disappears. Why? Because the Earth is round.
Then you zoom in, then you take a camera out and you zoom in, and the entire boat comes back into view, waterline and all.
No.
Yeah.
No, try it.
Yeah, so if a ship disappears from bottom up with your naked eye, and it completely disappears out of view, right?
Disappears out of view, yeah.
Yeah, and then you bring out a zoom camera, you can zoom back in to the boat.
You will.
It comes back all the way to the waterline, yes.
I can tell you that is not showing up because, well, of course I'm not talking about a couple of hours. Let's say you were there for, like, I don't know, the entire day.
If the Earth was flat, then the motion of the moon would not be circular as it is now. It would head directly to the center of the Earth.
No, the conversation's happening, bro.
No, it wouldn't.
I'm not going to be very nice to you guys. If you interrupt, I won't be very nice.
Yes. He's bringing another subject into the topic.
So eventually, a ship will definitely eventually go beyond any optical limit of any device. But if the ship disappears, bottom up with your naked eye, completely out of your view, and then you can pull out a zoom camera and zoom in, you can see the entire ship, waterline and all. So, did the ship go beyond a curved edge of the curved Earth?
No, I'm just saying this because I already tried and I cannot see.
Okay, so did you start out with a zoom camera or did you start out with your naked eye?
Well, in my naked eye, I couldn't see, but when I'm using a camera with a powerful zoom, still not there. But
it depends on how far away it is. Eventually, things will disappear bottom up and completely go out of the range of any optical device. I'm not talking about that.
Yeah, okay.
I'm not talking about that.
I understand
yeah, I'm talking about you're at the beach and you watch a boat disappear with your naked eye, and then as soon as it completely disappears, you pull out a zoom camera and you can zoom back into the whole ship, waterline and all.
But the question is, if you go, because this is been proven by other people, not me, because I'm not crazy to go on top of a really high place near the ocean, but let's say it's a building, a really high building. But if you go on top of this building, you can see them. Why? Because the angle. If you are in a higher position, you can see the boat.
It's actually incorrect because the boat's disappearing due to angular size. Like, have a look in the side chat, right? That the boat's disappearing because once something gets below 0.02 degrees, the human eye can't resolve it anymore. So it's due to the actual angular size that the boat's disappearing.
Let's say if you go to a building of 100 meters, you cannot see the boat anymore?
Yeah, because if it's still the same distance away from you, so as it gets further and further away from you, it just gets smaller and smaller. And once it breaches 0.02 degrees, then you can't resolve it anymore. It's just the angular resolution limit of the human eye. You could pull out a camera and zoom back in on it, but eventually it's going to fade into the opacity of the atmosphere.
But I'm saying that it's possible to see with a camera. But with a camera on the ground, you cannot see. But if you go above, let's say 100 meters, you can see.
Yeah, it is possible on the ground, right? So have a look in the side chat. Here, I'll repost it again. 1 second. So this is a giant ship. Now you can see that when he's zoomed out, okay, here it is. When he's zoomed out, you can't see the boat, right? And then he zooms back in and you can see the whole boat again. This is from right at the, like a few foot off the surface of the water, 6 foot or something. There's lots of examples of this as well. Sometimes it appears like it disappears bottom up, like if you've got ocean swells or if you've got a particular type of miraging effect or something happening like that. But most of the time, this is what happens.
Okay, so I have another. So I have another idea. So what about the shadow? What about the shadow of objects? If the Earth was flat, the shadow would be different.
Yes.
You know,
Wait, what shadow? What are you talking about?
a shadow of an object.
Why
Let's
would
say
it
you
be
have an obelisk.
I've noticed this really weird phenomenon where people hate flat Earth so much that they'll go out of their way to imagine reasons why it can't be, and those reasons are usually non sequitur reality.
No, it's
Absolutely.
okay. You can. I don't.
I don't want you to imagine why something can't be. I want you to tell me why it isn't by showing me curvature.
Yeah, so that's what I'm saying. So the shadow, because there was this a long time ago, there was this experiment that they made. They put two obelisks in different places.
Yeah, Eratosthenes' experiment works on a flat Earth and a round Earth, both equally, perfectly fine, and it works in moonlight. So you don't really have a gotcha at any point here. It doesn't mean anything.
Let me explain it like super quickly and easily, right? It was, if you assume that you're on a sphere with a sun that's an infinite distance away, right? Or if you assume that you have a closer sun that doesn't have parallel sun rays, right? It has divergent sun rays, and then that you're on a flat surface, it works out the same. Like if you have like a light in a room in your house and you put a stick under the light, it's not going to have a shadow, and then you put a stick on the other side of the room, it's going to have a shadow, and that's happening on a flat floor.
Are you assuming?
Have a look in the side chat. Have a look at what Sunny posted. There's an example.
Okay.
Even like the globe Earth scientists agree with this. Yeah.
Yeah. Okay.
Hello, guys.
Welcome.
I want to ask 2 questions if you don't mind.
Yeah, just hold on a second. We're just chatting to Axion.
Yeah, but wait.
You're next in line.
No problem.
Yeah, but
So it was only he was only able to do his calculation because he pre-assumed that the Earth was already a globe. He wasn't trying to test if the Earth was a globe. He was just using some mathematics to try to calculate a circumference. That's all. So he assumed that the Earth was a globe, and he assumed that the sun was an infinite distance away, and that the sun rays come in parallel. Now, based off those assumptions, he did some mathematics, and then he came up with the supposed radius circumference value of the Earth. But it was only because of the assumptions that he made.
Okay, so yeah. So wait, the question is: are you assuming that I don't know, the sun? How does the sun work in a flat Earth? Does it move around the
just
Hey,
the sun
Axiom.
moves.
Sorry, I was just going to ask him one question, DJ.
Let me just answer his question really quickly.
Is it
right? The sun moves across the sky. The sun moves across the sky, just like we all experience. Yeah, go ahead, AetherGrass.
I was pretty much going to say the same thing. I was just going to ask him what he sees the sun doing.
Yeah, because I was thinking, is it a fixed sun? So.
No. It moves across the sky. It goes in cycles. That's what creates the seasons and day and night.
Because I got the idea that. Okay. Yes. I think. Yeah, maybe the guy's wrong. I never checked this out properly.
It's all good, man.
Because if the sun is moving, the shadow is going to move too. Yes, obviously.
Yeah, exactly. Yeah, a lot of things you're going to find work on a globe or work on a flat surface. You know, some things are interchangeable, but you're not going to find anything that only works on a globe.
So you don't believe that there is the International Space Station taking pictures?
It's hard to validate exactly what they're telling us. I mean, there's definitely something up there, but is it in space, right? Is it really 250 miles away? And the size that they're telling us, moving the speed that they're telling us, it's hard to validate that.
You can see.
You can see it. You can see it. You can see something moving across the sky that looks like the ISS. Yeah, but whether it's the distance that they're telling us and the size that they're telling us, and in the environment that they're telling us of the vacuum of space, right? That's something that we can't validate. But yeah, sure. There's something up there.
Okay, what about?
Can I 1 second, Axiom? Can you look at the side chat, man? I just shared an image. I'd like you to see it.
No,
so if you have a look at what AG posted at 21 minutes after the hour, right? So that's footage.
I know.
That's footage from the Chinese, from the Chinese space station.
That's the testing.
Wow, man.
It disappeared. Oh.
And there's a lot more. That's just my favorite one from China.
Yeah.
It just shows that we have conflicting footage from the 2 different space stations that are apparent. Like they claim they're about the same height, roughly. One of them
What
shows
about-
a flat horizon. The other one shows a very curved horizon.
Okay. So what about the live streams they do, showing the Earth moving?
Show, man.
Huh?
It's a show.
Yeah.
It's a show.
Yeah.
But you know, there is other. We have a lot of satellites from different countries.
There's only like 31 that are associated with most of what everybody interacts with.
You have weather satellites that generate image.
These things they scan from overhead, and then they have to take that data and create an image from it. There's Rob Simmons created the Blue Marble 2.0 by taking all of these different layers and then bending them around a sphere, because it all looked. He admits that it looked kind of flat to him, and that he created an image of Earth as he imagines it to be. So it's not a picture. He created artwork that Obama later on said we took a picture of Earth. Straight up lying to everybody because it's not a picture; it's a composite image. That kind of mess happens all the time. That's just one thing.
Don't you? I don't know. Don't you guys think that it's a bit sophisticated? Like all these countries aligning in this theory.
It's a cult. It's honestly the largest cult on Earth.
But why? Okay, the question is why? Why do you do it?
I'm not saying that to be disparaging, Axion. I'm telling you that it is literally connected to an ancient religion, the cult of Pythagoras.
Okay. Yeah,
and the same thing overlaps with other. Do you know what the globus cruciger is, or cruciger? It's a golden ball with a little cross on the top, like a King's Jesus piece. That Popey ball's got people's minds wrapped around it, and that's tied into this heliocentric lore too, where he has dominion over the Earth given to him by God. It's a golden idol with a cross on top. I'll send a picture of it.
Okay, so what about the atmosphere? How does it work? Like, is it? Why doesn't the atmosphere goes away? There is no gravity?
Gases don't have an inherent shape, so it's kind of a contradiction in terms to call it an atmosphere. Like, atmos exists, we're breathing, obviously. Got 15 pounds of pressure here. How do you have gas pressure without physical containment next to a vacuum, though?
With gravity that nobody can explain.
But gravity is a pseudo force, it's a fictitious force. So since it's not a real force, how can it do anything?
It's complicated, gravity. Yes.
Well, it's not really that complicated. Like, there's something called the four-dimensional manifold, which is a fancy way of saying height, width, depth, and time. They created a mathematical framework and told people to story using it because math's a language.
Yeah, but
like, I can show you math that some nerd did that tells you how hard Superman has to slap a raw chicken in order for it to be fully cooked, but that doesn't mean that there's a Superman.
Mm-hmm.
The same thing applies to the curvature of the Earth and gravity and anything related to this. They come up with fancy stories, but none of them are testable, repeatable, provable.
Okay,
They're all unfalsifiable.
Chicken that hard, would it explode or would it cook it?
What was that? You broke up a little bit.
But,
If you hit the chicken that hard, would it explode or would it cook it?
I know, right? That's the real question.
If you eat a chicken,
No, it slaps. It was an internet meme thing a while back, a couple years ago, and some nerd did the math for how hard Superman would have to slap a chicken for it to be fully cooked. I'm just pointing out there's no Superman.
yeah.
The math is real, sort of, but there is no Superman.
So wait, I have another idea. So it was proved that you can see objects in assuming that you have planets. It has been proven that we can see objects that are when we can see the light of objects, so we can see them.
Even if things above our heads.
No. When we are in the when a planet is, so let's say we want to see another planet that's in front of you. How can you see this planet? Because the light is bending to the planet gravity, space-time, and if the light is bending, and then you can see in the back of another planet, you can see the other one in front. This is proven. This has been proven.
This is what I'm saying. It's unfalsifiable, though. So you can't. There's no way for anybody to debunk your story. Their options are okay, man, or cool story, bro. But they can't actually debunk it. That's what unfalsifiable means.
I think this has been proven because it's according to this to Einstein theory.
No.
No.
Math's not a force. It has no power to do anything.
No, I'm not talking about the math. The math it was gravity that is bending light, and then you can see something that is not that you cannot see if the object is in front of you. You can see it because, but if you use a laser, no, it's going to bend too. Hmm. What else? Well, there is a lot of questions.
Newton was talking about something like this at one point, and he pretty much said that you would have to be a madman to believe in it. Of course, he drank mercury and thought he would poop gold, so.
Yes, so wait, how can you explain these other planets in the sky?
Wandering stars that move overhead. The ground's not in the sky, so the things I see in the sky aren't going under my feet.
So the planets that you can see using a telescope, they are not spheres?
I never said that. I'm just saying that they don't go under your feet. All right, for example, you can have a puddle, and you can float bubbles over top of it. The bubbles are spheres. The puddle is not.
Okay. So there is planets in the sky, right?
I don't know what the hell they are. I see lights in the sky just like you. I can't go touch one or grab one. I can't study it.
But you can see them.
They're pretty to look at, but I can't tell you how far away it is. Nobody can.
Well, if you shoot a laser beam, it's going to be reflected, or a radio wave. You're going to get the radio wave back. So then you can calculate the distance.
Just saying that there's a lot of assumptions made with this heliocentric.
That's really easy to do, you know. You send like let's say a short wave.
You can't hit a star with a laser.
No, you don't need a laser. You need a frequency. You can shoot well, it must be strong. It must be really strong.
Oh, I understand that you're trying to get a point here, but there isn't one. Because everything that you're saying works fine overhead. But you haven't said anything that makes it so that the Earth cannot possibly be flat. Like, it must be round. Because everything you're saying works perfectly fine on like a horizontal baseline.
Okay, so, but I'm not talking about the sun. The sun is going to absorb. So I'm talking about the planet. If you shoot a laser to a planet, it's going to.
You won't reach a planet with a laser.
Huh? Oh, sure you do. You know, you have a lot of devices that you can measure, like a house, and then you use a laser and you get calculation. Because why?
Saying that you're not going to shoot a laser from Earth to Mars, like that concept is sci-fi.
Yes, you can.
That's not going to happen.
Well, let me search it up because I will show you.
Again, it'll end up being a cool story, bro, kind of thing. Because you can't actually prove it. You're just telling us something that somebody else told you.
No, but there is evidence of this X-rays.
Not at all, because the Earth still remains a horizontal baseline. You can have everything you're talking about above the floor. It doesn't change anything.
I'm not saying this is not related. This is not related to the Earth being flat or round. I'm just saying that you can shoot a laser and then you get the distance from other celestial objects. I don't know how you guys call it. Because you were saying that you cannot calculate the distance. You can. Doesn't matter if it's flat or round. You can calculate.
You're never shooting a laser to a planet, ever. Never going to happen. Never happened. Never will happen.
Saying silly things like that. You can't do things like that. Don't be silly.
Wait.
Don't make me get very angry.
Don't be.
Yeah, AetherGrass was right. When you said you can shoot lasers to planets, that's sci-fi. Science fiction.
No.
Yeah. Science fiction.
Well, you know.
You can shoot a laser to a planet.
I'm an electronic engineer, so I'm telling you that it's possible.
Yeah, no, it's not. Show us the data. Show us the documentation.
Yes. I'm gonna get it.
Yeah, we want the documentation, empirical data. What type of apparatus or equipment was used?
Yes.
What is its range?
You're in a server teaching people English, and you asking them for all that stuff is just, they don't hear that. They just hear.
Dude, I'm telling you, I'm an electronic engineer. What you mean?
They'll have to learn.
Yeah, there are no documented cases where anyone has ever shot a laser from Earth to Mars. 0.
Okay, hold on. You want data?
And I'll reiterate again, it'll be a cool story, bro, thing, because nobody's ever done that. For the same
Yeah,
reason
some data with a whole stack of assumptions attached to it that you can't validate. No doubt.
More sci-fi.
Just assuming it's going through a vacuum and all this bullshit that they can't validate. Meanwhile, we have countless amounts of long-distance observations here on the actual surface of the Earth, right, where we can see thousands of % further than you would be able to possibly see on a globe, right, over and over again.
Can I ask you guys,
Yeah, go for it, bro.
How do you like explain the acceleration of gravity on Earth?
The density of the medium. It's buoyancy and density.
Do you have an experiment for that?
Go drop something on the ground.
Okay, yeah, but it doesn't
Now
explain the
find something that
acceleration.
floats and drop that in the water. And then take a helium balloon and let it go.
Yeah, you can
Well, that
test
is
it over
because
and
of
over
resistance.
again.
If you put it
You
in
can
water, it's
test
because
it.
of resistance. It's not because that there is no
It's
gravity.
because of the relationship, right, between the object and the medium due to the density of the object and the density of the medium. Now we can vary and manipulate the medium and make the object change whether it's going down or up. For example, we can put an egg into a glass of fresh water, right? And the egg will sink to the bottom of the cup. And then we can manipulate the medium by adding some salt and changing the density of the water, right? And now the egg will float up. It will go upward to the top of the medium. We can do the same thing in a different medium of air. We could do it in the air using a different method. But it's very obvious that something less dense than the air goes up and something more dense will sink through it.
What if it's in a vacuum?
Well, then it will sink faster, won't it? Right? Things
Okay,
will
why is it 9.8 then acceleration? Well, you explain why there is
Turning back to
there is a speed, but you don't explain why there is acceleration. We're talking about acceleration, not speed.
its original position.
Things
After
will
force
fall
has
at,
been exerted. Go ahead, then.
yeah, things will fall at roughly the same rate in a vacuum, right? That's just because you've removed most of the medium, right? So if you're claiming a force, like a force of gravity, right? You can't prove that. We all observe the same effect. We know that it's only falling because it was lifted up and displaced in the first place, right? And it's just going to re-seek equilibrium within the medium. You're just removing almost all of the air, so you're making it extremely light medium, and things fall at roughly that rate inside a vacuum.
Yeah, but you can't
also
explain the acceleration itself.
Yeah, he just did. It returns back to where it was,
It
and the
doesn't.
energy that was put into it came from the person who lifted it.
Yeah, dude, it doesn't just keep accelerating, right? You drop it and then it falls at a certain speed, right? It just reaches its terminal velocity speed and it just falls at that rate. It's not just accelerating.
You know
It only
why
accelerates a little bit. It only accelerates a bit while it's reaching that terminal velocity speed.
There's a reason why a lot of folks are stuck on this, and it's because they've been trained their whole life to believe that if we didn't have gravity, they'd float off into outer space. But we're telling you that you are not in outer space. You are standing on the floor. You're on the ground, and everything that you see moving above you is indeed moving above your head.
So, okay, you're telling me that the density, that it determines what is faster, how objects must fall, right?
Buoyancy and density. Yes.
No, look, objects don't just...
That too.
Yeah, that too, bro. Look, the thing is, objects don't just fall by themselves, do they? Right? They just sit there on the ground if they're more dense than the air, and they never ever move, right? It's not until some outside source of energy comes along, like you, for example, and you pick it up, right? You have to force it out of equilibrium, right? Apply force to it to displace it, and then it's going to re-seek equilibrium after you release it.
Okay. Now, this is true if there is actually a gravity in the first place, you know that?
No, there isn't. You
you
need gravity, right? So look, you need gravity to have a globe, right? So you need to explain things like oceans sticking to the outside of a spinning ball in space and that kind of thing, right? On a flat Earth, in a stationary environment, so a flat Earth that's not moving in an enclosed system, we don't need that same thing, right? You need it to explain all of these things, right, that don't make any sense, like oceans sticking to the outside of a globe, for example.
Okay. So let me conclude what you are saying then. Because if there is density, then that means that is the reason of gravity. Okay, so if I put two objects, for example, a pepper, okay, in a room, that room is without air, without any, anything. Okay, it's a vacuum. Okay, and I put, for example, an iron. Okay,
yeah, and a feather. How about you add a feather as well?
Yeah, a feather as well, no problem. So they're gonna fall.
Yeah, because there's no resistance, right? You've removed most. It's probably
okay. Now here is my question: why down, not up? Why down?
Because so we can confirm that there's two primary vectors, right?
Okay.
It was already down, right? It's just reseeking equilibrium.
Yeah, you're more powerful than your gravity.
Wait, what?
But yeah, look, this is what the conversation usually comes down to, right? Like there's two primary vectors, up and down. We can agree on that, right? Okay. We can test that. Yeah, and I would say that nobody knows, right? Nobody can prove scientifically why down is down and why up is up.
No, the problem is with your theory. The problem with your theory, if what you are saying is true, the feather and the iron and the pepper, all of those objects, they're gonna just stay as they are in the vacuum, literally. That's what's
they're going to sink. They're going to sink.
Yeah, why they sink? Why they go down?
Because they're more dense. Because they're more dense than the medium.
You aren't listening. He's already told you several times.
Yeah, so the things that you drop, hold on a second, bro, right? So the things that you're dropping are more dense than the medium, right? The things that they're composed of is more dense than the medium. It's very simple, right? So it's a very light medium. You've removed almost all of the air resistance, right? So when you displace them and apply a force to them to lift them up, right, they're going to re-seek equilibrium, which is on the ground after you release them, because they're more dense than the medium. It's the same thing. You're just all you're doing is reducing the density of the medium by taking away the majority of the air. That's all. You put gas in there. What's going to happen if you use gas, right? The gas particles are just going to go in all directions. Where's your gravity now?
You mean the gas?
Yeah, the gas particles move at random in all directions. They don't have a downward bias. They don't have a directional bias.
Because the force of an atom is more more powerful than the gravity itself. That's why. And
they don't have a downward bias. They don't have.
Do you know what is density in itself?
The density of the object will be whatever elements the object is comprised of. Right. So say it's lead, right? A chunk of lead or a chunk of aluminium or whatever it is, right? It's going to have a certain density. So whatever mixture of elements or whatever that the object's made out of, right, is going to determine the density of the object. And then the medium relationship is going to determine whether it goes up or down once it's displaced.
Okay, so you're telling me the acceleration is because we have things have more density than other things.
Than the medium.
Yeah, exactly.
So this is the question. Well, this is the question. Give me one example within nature that this doesn't explain why something goes up or down.
Okay, how?
One example in nature where relative density doesn't explain why the object goes up or down.
Okay, it explains. Okay, I'm going to give you that. It explains, actually, if you look at it without studying, it explains why things go up and down, but doesn't explain why the more dense things go down and why less dense things go up. It doesn't explain that. Only gravity explains that.
Yeah, but you can't prove.
As you heard.
Right, so you're claiming the cause of the effect, right? We're not claiming to know why down is down and why up is up. We're explaining why things go down and why things go up.
That is the core.
Right? We're not explaining why down is down and why up is up, right? If you're making a positive claim about that, right, that gravity is the cause of the effect, then you need to provide an experiment that proves a cause and effect relationship, right? But you're not able to do that. We already know that for a fact. So I'm not even going to ask you to present an experiment that proves the cause being gravity of the effect, right? Because that doesn't exist.
Can I speak?
Sure. I mean, the other guy can respond if he wants to. I mean, I said that you don't have an experiment to prove the claim. I already know that.
I remember one. I was listening and I was thinking about something. So what about the GPS location system? Because you need to GPS to find the coordinates. You need
the ground positioning system. That one.
Mm-hmm.
Oh yeah, that's ground-based ground positioning system.
It's GPS. It's in you have satellites. You need 3.
Yeah, but you're making claims about the satellites that you can't validate.
Why?
Well, you're claiming that their satellites are in space, right?
Yes, because you can see them.
Yeah, and that they're orbiting around a globe, right? So you're going to need a globe, and you're going to need a vacuum of space, right? So you're going to have to, like, those things are required. Well, hold on a second, right?
Okay, go ahead.
You're claiming those things are required for your claim to be correct. So you need to validate the distance to the satellite, right? What medium the satellite's in, right? And that it's over a spherical Earth. I mean, those things, you're not going to be able to prove those things.
Yes, but I can prove that you can use the same system in different locations, right? Yeah. So
because you're not able to validate where the data is coming from, right? How the data is acquired. It could be coming from ground towers, for all you know.
I know my GPS chips use ground towers because it says it.
It's in ground towers. How can you use this system to another country that is far away?
Well, 99% of communication is done via undersea cables, right? That's a fact. Now, you can have repeaters as well. Yeah, you can have repeaters over distance to...
Repeaters?
Repeaters, yeah. Like repeaters, one station shoots the signal to another station.
So
and then to
are you saying that these objects that you can observe with your eyes. You don't even with naked eye you can see. And besides this, you can
What
use
objects are you talking about? You're thinking that you can see satellites with your naked eye.
some you can,
Right, but you're claiming that.
but you see a small thing, obviously.
Yeah, you see a little light in the sky.
Yeah.
Right, but you're not able to validate what the distance to the object or how big the object is or anything like that.
You can use radio frequency, and you can even communicate with them. That's how GPS works. GPS sends a signal. Sorry. GPS gets a signal. Gets a signal from 3 different locations, and then it triangulates. And this same system works everywhere. So it's not the same satellites; it's different satellites. But if they are,
you're making claims, but you're just making the claims, bro. Stop making the claims and provide evidence for the claims. We all know what the story is. We know the story better than you know the story.
Yeah.
What I would need from you is the size of the satellite. Let's see if these lights in the sky that you think you are seeing, and they're supposed to be satellites, is true. Let's these objects is correct. So what I would need from you is the distance to the satellite, maybe even some kind of serial number or identifier of said satellite to know the size of it, the distance of it, and what kind of angular size we can expect out of that object at that distance.
So, did you ever try seeing with a telescope?
Friend, it doesn't matter. We need the angular size calculation for the object that you're claiming. So pick one.
No.
Pick one of
You can see.
Pick one of the lights in the sky and tell us how big it should be according to angular size, the distance, and the size that it is. Just go ahead and do that for me.
So, are you saying that these ground objects that are used for GPS are ground based? So they can how tall they are? Are they?
What, you're asking me a question now about what? Ground-based towers?
Yes.
Cellular communication? Radio communication that's been around since this has been around since the turn of the century. Okay, ground-based towers and ground-based communication.
Sorry to interrupt. Not that. I'm talking about GPS.
What are you talking about then?
GPS uses satellites.
No, it doesn't.
The name is Global Positioning System.
So what? I don't care what the name of it is. I want the evidence for the claims that you're making. I myself have actually never seen any of the satellites that you're talking about. And I look, dude, I'm not getting mad. I'm just telling you. You are making claims, but you're not actually providing the evidence. Please don't repeat the story that we already know. I already know the story that you're telling me. I've heard the story. I've heard the story about Santa Claus. The problem is there's no Santa Claus.
Okay, wait. So what about satellite dishes? Where they are pointing?
What about them?
Where? They are pointing where?
Into the sky. It doesn't matter where they're pointing.
Yes, but don't you think that the satellite dishes are receiving the signal from something on top of the Earth?
Let me paint you a different picture as far as satellite dishes are concerned.
No. Just ask me.
No. I'm going to tell you a story about satellite dishes. Let's see which one's more plausible, okay?
You can see Starlink.
Excuse me. You just asked me about satellite dishes. I want to give you an alternative story,
Yes.
okay?
Please.
Okay, no problem. So what would you say is more plausible? Let's just see. Is it more plausible that there is some sort of machine or technology that is falling around the Earth that, by the way, hasn't been measured to be a globe, so falling around a non-existent sphere in a second law of thermodynamics violation called space, right, at 17,000 miles an hour, give or take, unless it's geostationary, but that also requires a flat Earth, but whatever. And then you are getting satellite TV from this geostationary piece of technology that is exposed to one of the most harsh environments known to man. Or is it possible to bounce radio signals off of the surface and then receive them in the ditch?
Yes. So yeah. But how do you explain this ground? You're saying that there is no satellites?
No, I've never seen a satellite. No one has provided any evidence of a satellite. They're actually not able to exist in the way that you imagine them, these machines that are falling around a globe because of gravity, which also doesn't exist. So all the things that you're telling me, the story, all of the things that are compounding, none of them exist.
Okay,
none of them exist.
I understand.
Okay, so there's
so the question
there's no globe.
Wait.
There's no globe, right? There's no globe, no gravity, no space.
I didn't speak about globe. I'm just asking you a question. So
but wouldn't it have to be a globe?
Wait. If these satellite dishes are pointing to the sky, so and they are getting a signal, where does the signal comes from?
Like I told you, is it possible? Because I actually don't know the answer to that. But is it possible that there is an easier way to do this type of communication without there having to be some kind of machine falling around a globe tethered by gravity, which neither the globe or the gravity actually exist.
Did you? It's difficult to explain gravity. You know.
I know because it doesn't exist.
It does.
It exists. It's you.
Okay, can you get me? I want you to get me a sample of this gravity. Where is it?
There is no samples. You can see.
Guys, you need to prove that, not us. I'm sorry, but I asked you.
Wait a minute. We need to prove the non-existence of something? No, I'm sorry. You have the positive claim. You have the burden of proof. Get me a sample of the gravity somewhere, please.
No. I'm not talking about gravity. So I'm talking about. So can you explain how you can talk with radio waves to these machines on
straight lines?
Sky,
yeah, the straight lines. Straight line communication. Radio waves travel in straight lines.
Okay, so whatever. So you can see them with a telescope. Did you guys ever use a telescope?
I've never seen any satellites with a telescope. I want you to give me the distance. Give me one of the satellites. I want to see it. I'll get my telescope out. We'll find it.
International Space Station.
Exactly.
Okay, the International Space Station. So this piece of machinery that you believe is hurtling around the ball Earth that doesn't exist, tethered by gravity that doesn't exist. Excuse me, I'm not done yet. So you think that this machine being hurtled around the Earth at 17,500 miles per hour around a ball that hasn't been measured and doesn't exist in space, that's not possible, tethered by gravity that doesn't exist, you think that's actually what you're seeing, do you?
No.
Okay, good.
I'm just telling you to use a telescope and see it by yourself.
Okay, and what will that prove to me if I see this blip of whatever it is in the sky? What's that going to tell me?
You can see it very clearly. You can even see the name of United States there.
No kidding. I want to get me a photograph of this, please.
No, I'm not. Yes, I can give you, but you don't believe.
Give me the photograph.
You're going to say it's fake. I'm telling you.
Just give me the photograph. Well, we are going to do the math that it takes to see whether or not this is even possible. So we're going to go by the size of the object and the distance that it's at, and we'll see if the angular size matches.
No, the angular size matches. What you mean?
Okay, no, but you're just saying that. I want to see the evidence. I want you to do all the math for me. Go get me the math and the image and the size, and we'll see if it's true.
Yeah, obviously you're going to see it for a while because it's.
Friend, I just want you to go do it. I don't want to hear any more of your stories. I don't want to hear any more of your excuses. I want you to go ahead and get me the distance and the angular size, and we'll see if it matches up. We'll see if it's even possible to see an object at that distance. What is it, 120 miles from the Earth's surface? Something about the size of a commercial airline jet at 120 miles? Good luck with that.
Yeah, 250 miles.
Oh, excuse me, 250 miles.
So what you want? You want what you want to see? You want to know the distance? What you want to know?
Yeah, what's the distance of the ISS? What's the distance of the ISS?
That's all?
That's where we're going to start. You're going to do all the math for me, and we're going to see if this is possible.
What math you want? Because just tell me now.
We're going to figure out what the angular size of the object would be at 250 miles. You and me, together. Let's go.
Okay. Are you sure you can do the math?
No, this is your claim. You're going to do all the math for me.
Oh, okay. You're saying the angular. Do you want to know the?
OMG. How are you going to measure that angular size? How are you going to measure that angular size at 250 miles? I can't even see an airplane when it's 6 miles away.
He's a professional time waster.
Right.
So the ISS is supposed to be the size of basically like 2 jumbo jets.
So
and so do you think you can see 2 jumbo jets at 250 miles when you can't see a jumbo jet after 5 or 6 miles? Yeah, I was talking.
It was
yeah, you can't see a aircraft beyond like 5 miles.
I said we were using a telescope.
You can't follow something in the sky. You can't follow something with a telescope moving at 17,500 miles an hour. The end. I can't even keep my camera on the moon because the moon moves so fast.
That's funny because I saw it many times.
Yeah, do you know how fast the ISS would be moving across the sky?
So you don't own a Nikon P900. Go ahead and get one. Set it on moon setting, so it just automatically just sets up the zoom and everything. And then when you point to it, get it all lined up and walk away for a minute and come back and tell me where the moon's at in your screen after you zoom in.
Yeah, you can constantly have to keep adjusting. I've had that problem.
Exactly. That's why I said you can't even follow the moon. You can't follow the moon. You can, but you need a sky tracker like I have and set it on moon setting, set it all up, get it pointed to the North Star, get everything working, and then it'll track it and keep it right in the center. And I can just hear it as the motors are turning.
So can I ask something?
1 second.
No, you're going to get the evidence. You're just going to get the evidence for the things that you claimed. Excuse me. Are you the guy that's still supposed to get me the angular size calculations?
Yes, yes.
Okay, go get him. I don't want to hear another word or claim out of you until you get the information I asked for.
Okay, relax.
No, not relax. You're going to go get it.
Yes, I'm taking care of it.
Yeah, okay, no problem. I don't want to hear another word. Go ahead, DJ.
I think maybe Hicamera wanted to ask some questions, or if we got anyone new in here.
Yeah,
Dino, welcome. Iris.
I have another question since the last question. I'm going to do research.
Well, can I make a request? Can we potentially talk about the thing that the topic of the channel, which is the Earth?
Yeah, it's about the Earth.
Okay.
Yeah. Now, if you go to north side of the Earth, if you believe it's a globe, okay, then you're gonna see stars moving, counterclock, okay, like
east to west,
from right to left. Exactly.
Yeah.
So if you go to northern part of Earth, it's gonna. I'm sorry. If you go southern part, it's gonna go clockwise. So why is that happening?
East to west as well.
Still turning east to west.
Are you sure about that? You have about
100%. I'm from Australia, and you could just look that up, right? You could just Google like, do the stars move east to west in the northern and southern hemisphere? It will say yes. It depends also which way you're facing, right? So if you're facing like, they're always going to be going east to west, but whether they look like they're going right to left or left to right or clockwise or anti-clockwise, it depends on which way you're looking. It's like your orientation makes a big difference.
I do have a question, guys.
Well, 1 second, because we'll get your question next, because we'll just finish off the question with Hicamera first.
Yeah. So you're telling me, do you have a footage, guys? Can you send it to me if you have it?
Yeah, there's actually a great video that shows this. I'll see if I can find it. Which heretic was in here?
By the way, are you a flat earther?
Me? I'm not.
You anti-globalist? Are you like pro flat Earth?
Yeah, I'm on the flat Earth side. Yep.
Okay.
Are you angry at him about that?
No, I'm just like trying. Like, I just want to know who's the pro flat Earth and who's like I'm the scientist guy. You know, that type of thing. You know.
You sound like a science denier already.
Yeah, we've got a whole mixture of people in here on both sides.
I mean, but for real, like, who's like really thinking that the Earth is flat, and who's just like joking?
You mean just like we experience?
We know it's flat. So you're asking us if we're flat earthers? We're the ones that are going by reality. What reality? How reality presents?
Reality. What is your reality?
It's flat inflationary, and it's contained. That's how we have 14.7 psi at sea level.
Hydrostatic equilibrium. Water lays flat and level on the top.
You know, well, just 1 second, right? Because a lot of people have a complete misconception of what we're claiming when we say the Earth is flat, right? So just quickly, we're not claiming the Earth is a disk planet floating around in space, right? No one's claiming that. We're not comparing a globe, which is an object, to like a flat planet. So it's not like that. We're not claiming to know the shape of the Earth, right? We're testing the globe, and we can't find any curvature over huge distances consistently, right? So we're doing research and putting the mainstream claims to the test, and they're failing every time.
Hey, that's weird. I mean, bro, if that is true, you gotta win a fucking Nobel Prize.
Thank you.
Yeah, well, instead, our information gets censored.
Go ahead and put our room up for a nomination for it, and just put one of our names in here, and we'll show up to collect $1 million or whatever it's at now, and that's awesome, dude. Glad you agree with us.
Yeah, Tommy, if I had $1 for every time I heard that one, I'd already be rich.
If this shit is true, bro, you're gonna be. I mean, if this were true,
well,
you should
think about this. Well, it is true, and we can prove it.
Fucking Nobel Prize.
Well, the thing is, right? If they tell us the exact size of the globe, right? So that means if you go to a large body of water, like a 20-mile lake, for example, or a 10-mile lake, we can calculate very easily how much curvature there should be over that distance. Now, we can go and start conducting different tests over that body of water. And we have done so, and we can't find any curvature. And it's been repeated in different locations over even larger distances than that, right? There's no curvature. It's not like there's a little bit of curvature. Like 1 second. Right, so dude, Julia.
But shut the fuck up. Let him talk.
Yeah,
I'm sorry.
Thank you. No, that's all right. Look, okay, so over 20 miles, there should be a 260 odd foot, right? 260 something foot of curvature. But we can go to a 20-mile lake and set up a camera just like 5 foot off the surface on a tripod, and we can zoom in all the way 21 miles across the lake and see the shoreline on the other side of the lake. Consistently, we have observations like this. We've got videos that have been done in high definition showing the entire observation process, all the variables. And yeah, like it's not just the long distance observations. People have gone out to disprove flat Earth, right? People that are experts in optics using very high-end equipment, shooting powerful lasers across the surface of the water, right? Over like 20, 30, 40-mile distances, setting out to disprove flat Earth, and they're able to see the laser from the other side of the lake. So a lot of these people that have gone out to disprove flat Earth have become flat Earthers in the process.
Yeah.
So yeah, it's yep. Go ahead.
Yeah, I've searched. Yeah, so I have searched it, and it looks like sometimes high definition videos that are taken close to the ground or sea level often can seem flat because cameras have limited field of view, or there could be a lens distortion. So what do you think about that?
Well, what we're it's not going to allow you just some lens distortion, right? That's not going to allow you to see over physical obstruction, right? So if the shoreline, say you've got a friend on the other side of the lake, right, and he should be hidden behind 250 foot of curvature, right? A bit of lens distortion isn't going to allow you to see over a hill of water.
But what about the GPS system? What about aviation, satellite communication?
Well, the aviation industry, if you have a look at I know an aerospace engineer who works for the government. He's a globe earther, but he said that all of the calculations that they do are assuming a flat stationary Earth. So now if you have a look at the FAA flight dynamics summary manuals and various flight design manuals, right, they clearly state that they treat the Earth as flat and stationary. There's tons of pilots who have done interviews who are flat earthers as well, and they say that they're trained to treat the Earth as flat and stationary. So the Earth is generally utilized as a flat stationary plane, just like we all experience.
You're not suggesting that my P900 camera, when I zoom in on stuff, is zooming around the ball, are you? Is that what you're saying? Cameras make it look flat because it's zooming around the ball? Say that for the YouTube viewers so we can clip that one, please.
I'm sorry, who are you talking to?
The guy, the glober who thinks cameras don't work because for some reason, there's anomalies when you're using a camera to make it look flat.
But how do you argue against the millions of videos that have been taken from the space that show the
space is fake? Space is fake. So they'll just cut you off with that. Space is fake. I don't want you to get mad at me. I don't want you to get mad at me, but space is fake, so you can't use that one yet. You can use space after you prove the Earth is a ball.
So about the pilots thing that you just mentioned, you said that the pilots treat Earth as a flat surface, kind of. So I looked it up, and it says that can be misleading because they kind of approximate flat Earth, but it's only over short distances. It says
they don't ever take.
It's for simplicity. Flight planning over short distances can use a flat Earth approximation, especially in initial training or basic navigation. This is because the Earth's curvature is negligible over small regions. Oh, I'm sorry. Small regions.
I mean, planes go very fast. You got to remember that. So over just 100 miles, you have 6,000. Well, how much curvature do you think there is over 100 miles? Right. You got to remember, planes go about 500 miles an hour. Now, just over 100 miles, there's 6,666 foot of curvature over that distance, right? That's a huge, huge amount that they'd have to account for. Now, they treat the Earth as a flat, stationary plane, right? And they say it's for simplicity, like for simplification purposes, but how convenient, right? A plane designed to fly over a flat plane is training the pilots to treat the Earth as a flat plane. You know, I mean, that's just the facts. I mean, and there's tons of pilots that are flat earthers as well. Like,
that goes to the black box data, so you can see that this is from a flight that crashed, but the people didn't die. You can see the engines twice where the engines blew out. The first one engine blew, the second one, now they lost both. That's when they crashed. If you look, it's a flat Earth under it. Isn't that crazy how the black box knows it's flat?
And what was that, Redwin? 500 miles? Or something? 1,000 miles?
No, the one section in the middle is 1,000 miles. That's like a 2,500 mile flight or something.
And they didn't adjust the pitch. They didn't adjust the pitch of the plane over that entire distance.
No, there were none made.
What is your YouTube channel? Do you have a YouTube channel?
Many YouTube channels.
You mean just like the YouTube channels that have flat Earth content, or the ones that are live streaming this conversation?
Well, the one that's live streaming, I guess.
Yeah, so if you go to the top of the chat, you'll see 24/7 live, and you can click on the username, and it will have a link that takes you to the YouTube channel.
Okay, you actually got subscribers. Okay.
Yeah, there's some. Yeah, I mean, it's shadow banned. I mean, it's super censored. Right. So in 2015, 2016, flat Earth was quickly becoming the most popular search term on all of YouTube. And Congress got together with YouTube and Google and whatnot, right? And they agreed that they're going to censor flat Earth information.
I mean,
There's a video
even though
yeah.
it's like the problem with the flat Earth theory is the fact that there's not really a point in making everyone believe that the Earth is flat. Like, what's the point? What's even the point of
We're just sharing information with people that are interested in having a look. You know, it's a very interesting topic.
But what is
for
the
people.
point of the government? I'm just saying. I'm sorry. I was saying, what is the point of the government trying to make everyone believe that the Earth is flat? I mean, it's crazy, and you got.
You mean believe that the Earth's a globe?
Well, it's actually not a globe. I think the correct term is geoid.
Right, but it's roughly a perfect sphere, right? It's just technically not quite a globe. They say it's like 0.3% different.
Yeah, but
by the way, I already showed the mathematics.
What science can prove. I can believe I'm a fucking unicorn. It's like I can believe I'm a fucking unicorn.
Whoa, just wait a minute, Axion.
Yeah.
Okay.
Yeah, so what were you saying about a unicorn?
No, nothing. Nothing important.
Yep, nothing.
I already shared the way you can see.
Okay, terrific. So, this is the map that we're waiting on, right?
Hey guys, I have a unicorn in my garage. Do you Globers believe me?
Of course, I believe you.
Of course you would. You believe anything anybody tells you.
Yeah.
Hey, what's up, guys?
What's up, man? Hey, 1 second. I think Seisu was going to go over some information with Axion.
Did you saw how to track the international with the telescope?
No, I wanted you to give me the distance to it and the angular size. Did you do that? Did you get those calculations for me?
Yes. Yes.
Okay, what's the distance?
You have three. I mean, two. You have 2 pages. What you
2 pages of what? Yeah, what is the distance to the ISS from the surface of the Earth?
Look, you can read.
No, I'm actually driving right now, so I'm going to ask you kindly to get me the information.
6,371
6,371 what?
kilometers.
Kilometers.
Yes.
Okay. So, at that distance, with the size of the ISS, how long is the ISS, or how big is it?
It's visible. It's visible for 5 minutes.
Excuse me, how big is the ISS?
Look, I didn't calculate everything about the ISS.
You came in here to interrupt the conversation. You didn't get what I asked you to get?
Yes, I did.
Put yourself back on mute and get those calculations. I don't want to talk to you again until all the math is done.
Calculations are in the side chat.
He's not asking you.
Don't shout to me because I'm not shouting to you. Be polite.
No, I asked you to do something. You came in here and interrupted people. I was thinking that you did the task that you were supposed to do to make sure that the angular size is accurate of the ISS. I don't know why you're talking over me now. That's quite rude, right? So, you interrupted people in a conversation, and you have not gotten the information to support your claim to this point. So, very rude.
In the side chat.
Okay. Listen, I'm driving right now, so you're going to have to give me the numbers. You have the distance. Now, how big is the ISS? How big is the ISS?
What numbers exactly? Wait, I can do the calculation, no problem. But exactly, what do you mean by calculations? I want to understand. You mean you want to compare if it's in the footage?
Well, I wasn't talking to you. Why were you bouncing in here trying to do something when I'm talking to somebody?
There is a billion calculation you can do on the ISS.
No worries. No worries. So we have the distance. No worries. We have the distance. Now, what is the actual size of the ISS?
So, as I understood from you that we have the actual size of the ISS, okay, which we can search it up, and you want.
You guys haven't even looked at this yet?
Okay. Let me talk.
Relax.
Please.
All right.
So you want.
These are the things that I already asked for. Hold on a second, both of you. I've already asked specifically for the things that I wanted you to get, and you apparently did not listen. That is also rude. Why are you being so rude to me?
Let me know when you can read.
Didn't answer. I wasn't the one who asked for. You didn't ask me. If you asked me, I would.
I'm gonna read to you.
Okay?
Yeah, so you're the white knight now that's helping the guy that won't get me the information that I'm looking for to support his claim.
What information you want? Tell me what the
I just told you distance, and then I want you to get me the actual size, and then I want you to calculate the angular size of that object at that distance.
I already have the data.
Okay, so how big is the actual size of the ISS?
Don't be rude. Actual size? The size?
Oh my gosh, yes, the thing that I've asked for 4 times.
A lot of questions.
Oh, wait.
4 times I've asked for this in the last 3 minutes.
My man, I just want to understand what calculation exactly you need, okay?
So I've already told you 3 times.
Okay. Tell me if I'm saying it's true, okay? If it's true, if what I'm saying is what you want, then I'm going to work on it, okay? So you want the size of the ISS, which is, for example, point B, and the Earth, which is point A, and the Sun, which is point C, and you want the distance.
Holy cow! No, I didn't ask for any of those things.
What?
English isn't good.
If you want to do the calculation, I can do it, no problem. But just tell me what calculation exactly.
Give me the angular size of the ISS. You're done here, sir. You don't have to talk anymore. The white knight here is going to do your job for you since you failed at it. Okay? So, Mr. White Knight, you're done, sir. I want you to go on mute now, or I will mute you.
Okay, you guys don't want to listen.
You have a hero now that's going to save you. You failed. Now the hero is going to save you.
There is no hero, man. We are not spies for NASA or something. We're just normal people here talking. Okay?
Who said that? No one said anything about being spies for NASA.
Why are you screaming?
What I would really like is for somebody to actually listen.
Are you talking about Israel and Iran?
You don't listen to nobody. You just
says who.
You don't think listen to nobody. You just shout.
Okay.
But we're shouting, bro.
So
Now, bad, dude.
Is somebody going to listen?
Sure, yeah.
Okay. I want you to calculate the angular size that the ISS should be viewing it from the Earth.
That's what I said exactly. I'm telling you, point A, which is the Earth, point B, which is the ISS, and point C, which is the Sun, and through that,
no.
I'm gonna do that.
Why in the world would you even bring the Sun into this? I asked for angular size, not the Sun.
To do it without the Sun. There is no way to do it without the Sun.
I don't even think you know what I'm asking for. I don't know why you're flipping out.
You might not even understand anything that we're asking for. The Sun is not involved in what he asked you for. And I'll say it nicely. The Sun is not involved in what he asked for.
I'm going to give it to you. It is impossible, okay? Focus on this.
Now it's impossible.
Without the Sun, yes, it's impossible. I'm telling you, it's impossible.
You don't know what we're asking for. You don't know what we're asking for. I can tell you don't know what we're asking for because you're bringing the Sun into it, and that has nothing to do with what I'm asking for. So you are misunderstanding.
It's logically
impossible. It is not. Dude, now you're freaking out and chanting, and I don't know why you're doing that either. I think as the White Knight, you have also failed today, so it's time for you to go ahead and go on mute.
Look, man, when you need to calculate something in math, you need to know.
Look, man.
Okay.
Really? Okay, so do I need to know where the Sun is when I'm calculating angular size?
My idea is to have a footage for the ISS, okay? Going through.
No, that's not what we're talking about. That's not what we're talking about.
This is the only thing I have to give you the.
You're done. Okay, I will unmute you, but I just want you to know I don't want to talk to you anymore because you don't know what I'm asking for. DJ, if you would like to continue the conversation with the gentleman that you were having, even though you were rudely interrupted by two people that refused to understand the question, please do so.
Alrighty. Do we have anyone that wants to ask a question?
I think Julia's up.
Oh, yeah. Julia, you there? Anyone else? Questions about flat Earth? You want to present any globe evidence? All right, well, I'll present something and we'll see if anyone wants to ask questions about it. Okay, so this is a 21-mile observation. Absolutely destroys the claimed globe mathematics, specifically the curvature and the distance to the horizon. Right, so we must have a particular distance to the horizon based off the height of the observer, if the Earth's a globe, and we must have a certain amount of curvature over a certain distance, right? So 21 miles, you would have to have 293 foot of curvature. The observation height in this observation is 5 foot, right? So based off the radius value of the globe, we can calculate that the horizon would have to be at 2.73 miles away. Okay, so a small clip from the full-length video is in the side chat. What we can see in the observation, right, when he zooms in, you'll see that there's no horizon whatsoever over the 21 miles, and we can actually see the shoreline on the other side of the lake. Now, behind the shoreline, we can see a small town and a giant white smokestack. Okay, so the shoreline itself should be obstructed behind 230 foot of curvature, but there's zero curvature present, zero horizon present. This is impossible on a globe, right? We can also see that it's extremely clear conditions, right? There's no miraging effects or anything like that present. So I'll just put a link to the entire video if anyone wants to check out this particular video. Right, so also in this video, they don't just do this one observation. They wait until it gets dark, and then they do it again. And even at nighttime, you can see across, you can see all the lights on the town that should be hidden, and you can see the lights reflecting off the water on the other side of the shoreline. And then they actually take high-powered lasers, and they shoot the high-powered lasers across the lake towards each other, right? So there's one guy on each side of the lake, 21 miles apart, and then they shoot the lasers across once it gets dark, and they can both see each other's laser beams, right? So those laser beams should basically hit the water at 2.7 miles away, right? And not be visible beyond that distance because of curvature. So I'll post the full video. So this is just like one of many observations that we have. And again, you can see even just in the thumbnail of the video, like it's such clear conditions, and we can see a perfect specular reflection on the surface of the lake, right? That's like a mirror, basically. We can see a perfect mirror image of the mountain in the background, right? Once again, showing that there's no curvature over that distance, right? So there would have to be 293 foot of curvature over that distance. You wouldn't be able to have a specular reflection, because to have a specular reflection, obviously you need a flat surface, a mirror-like surface. Yeah, so once again, if anyone else wants to jump in and ask questions, you're more than welcome to. If not, I'll present another observation, right? So here's another observation. This is done at another nice still lake, this time in Canada. Now, we can see the full-length video is posted there, but there's some clips taken out of the video just above it. And what he does here is he holds the camera 3 inches above the surface of the water, and he's zooming in. And as you zoom in, you'll see 2 peninsulas on the right-hand side. The second peninsula is just under 14 miles away, right? So according to the globe math, you should have a horizon distance of 0.6 miles from a 3-inch observation height. Once again, there's no horizon present at all. And we can see the little rock peninsula that's going out into the water, which should be hidden behind the curvature of the Earth and obstructed by 120 feet. So this is another example of an observation that's impossible on a globe.
To me, that observation there, DJ, is like one of the most wonderful silver bullets, right? 3 inches and 14 miles. What are you going to say about that?
Yep.
I'm going to say welcome to Flat Earth.
Exactly. And the quality of that particular video is so good. I like that too.
Yeah, really good video. Super clear conditions.
Yep.
No waves. No visible like distortion or miraging or anything. So yeah, anyone that's looking at this observation, right? Like when I say the horizon has to be at 0.6 miles, right? It has to be there if the Earth's a globe. There has to be a physical horizon line there, right? And anything that goes beyond that would have to start to become obstructed by the curvature of the Earth, right? That second peninsula has to be hidden behind the curvature of the Earth, right? Over the 0.6 mile horizon. There's no there's no getting around that. It has to be there if the Earth's a globe of the size that they tell us.
Does everybody calm down now?
Any proof of the globe yet?
Nah.
That was a rhetorical question. I was hoping to hear one of these globers speak up. How we doing, Drace?
I'm getting ready for sleep.
Sounds relaxing. We got some clickable material today, for sure.
Yeah. Julia, you were hot micing earlier. I'm pretty sure maybe you had question. But if you want to ask anything, just open your mic. Feel free.
Can anybody read that guy's name on the top left? Ask him if he has any questions.
He took off. Oh, he came back. Necros, maybe you, Necro's deafened, but I'm pretty sure Necro knows how to read it.
It's nice having people all over the flat Earth.
Definite, bro.
Yeah, we're definitely going to be expanding more and more if we stay in a room this large.
Yeah, definitely.
Yeah,
So,
definitely.
EAU, no. If I don't know if you can open your mic up, but you seem to have some pretty good questions. But yeah, what's up, man?
Yeah, hello. Can you guys hear me?
Hello. Yes.
Okay. So
Welcome.
I don't. I find the evidence that you guys are providing very compelling, right? The fact that you would be able to see the curvature over the distances that you guys are describing and how that's clearly not present. So I'm a bit of a skeptic, I'm not gonna say you guys are wrong, but I'm not gonna say you guys are right either, right?
That's fair.
Well, that's how we got here. That's how we're skeptics. That's how we got to this position as well.
Definitely.
So, yeah.
Okay, so are there atmospheric conditions that would be able to somehow influence what is perceived at these distances?
No, absolutely not. I mean, once you have a look into different atmospheric conditions that can alter what you're seeing, it's by a small amount, not by thousands of percent, like we're seeing. For example, standard refraction, right, would just make the horizon 7% further away, right? And then extreme refraction would make the horizon up to 15% further away. So it would take it from, say, 2.7 miles, where it should be, and make it appear like it's like 2.9 miles away or something like that. Not completely make the horizon disappear, and all of a sudden, you can see over 293 foot of curvature and everything looks perfectly flat, right? There's no type of atmospheric conditions that can make that happen. And when you have more extreme atmospheric conditions, you have miraging effects, and they're super obvious. Everything's like distorted and blurry, and you see some crazy things in the distance. They have specific characteristics.
Okay.
And
my second question would be, I mean, fair enough. That's a really good answer, actually. So second question would be, how do you guys explain the stars, or the sun and the moon?
We don't usually speculate about things we can't validate, but what we do, we all observe the same thing in the sky, but most people were taught a specific story about what we're looking at from a young age, right? Like how big they are, how far away they are, all that sort of thing, that they're in a vacuum of space and all that sort of thing, right? What we say is that they move across the sky in patterns, in repeating patterns, right, in cycles. So I would describe the sky like a big clock. Like we can use it to work out months and years and different cycles, all sorts of different things, right? It's very handy. So, the stars all rotate east to west, and they reset back into the same positions roughly each year. And then there's planets, which used to be called wandering stars by the ancients, right? They do the same thing, right? They move around us east to west, but they take their own specific paths, different to the stars. And then the same with the sun and the moon, right? They also take their own specific paths, and then we got the sun, which is, you know, responsible for day and night, obviously, and the seasons. Right, so the particular path or the cycle that the sun's taking means that it's moving over the Earth, just like we see it doing. But at certain times of year, it will migrate slowly, you know, inwards and outwards, right? So sometimes it will be summer in, say, Australia, but at the same time, the sun, you know, is lower in the sky in Europe. So it'll be winter in Europe, and then 6 months later, it'll be, you know, summer in Europe, and then it'll be cold in Australia. So at midday, when it's summer, the sun's right above your head, right? When it goes over your head at midday, it's right above your head. But when it's winter in Australia, right, the sun's, instead of being above your head like it was in summer at midday, right, it's like much lower in the sky. But someone in Europe will see it directly above their head. So yeah, I don't know if that makes sense, but it makes a lot of sense once you think about it, once you look into it.
Okay, and I think this is a more mainstream question, right?
Yeah.
Usually people will bring up satellites, but I myself question satellites to begin with.
Yeah. So I mean, if you Google and try to find a photo of a satellite in space, right, all that's going to come up is a whole bunch of cartoons of satellites in space, like obvious CGI cartoons. Now, we're not denying that satellites exist, but we need to remember that 99% of all communication, right, like the way we're communicating right now, and almost all communication is just done via undersea cables, right? It's like 8 times faster than any capability of a satellite, right? So it's obvious that people would use cables, and that's the way that communication works. Now, there's definitely some satellites in the sky, but whether they're actually in a vacuum of space orbiting around a globe, right, that's something that's very difficult for us to validate, or for anyone to validate. We know that NASA's has a massive satellite balloon program, right? NASA's first satellites were literally Echo 1 and Echo 2, which are just big balloons, basically, with satellites attached to them. And
1,000 miles up.
Yeah, and they can stay up there for a long time as well, and they can maneuver them around and all that sort of thing, and they can get them taking advantage of wind currents and things like that. And NASA still launches tons and tons of these balloons all the time, right? And NASA's actually the largest consumer in the world of helium.
And
so
Echo
that's some
1 and 2
interesting.
traveled the same speed as they say that the ISS is now. Those 2 balloons went that speed.
Yeah, so it's very hard for us to validate the exactly what is going on at heights that's too high for us to validate, like satellites, or what the planets exactly are, or exactly like how far away is the sun and exactly how big is the sun, you know, things like that. Stars, you know, stars are another mystery. You know, you zoom in on stars and they're very, very interesting looking, geometric patterns, different colors, but we can't validate what's in the sky, right? So we try to stick. We don't have a replacement answer for every single thing that the globe site claims. We're like empiricists, and we stick with what we can validate. So we can test if the Earth's a globe or not, but we don't like claim to know exactly how everything works, and we're not even necessarily claiming the shape of the Earth, right? So flat's not a shape; it's the description of a surface.
Oh wow. Okay, so you said you have receipts for NASA being the #1 consumer of helium. That's funny. Okay.
Yeah, I think they actually own like most of the big helium companies. I've heard that NASA actually like bought them up or something as well. I can't confirm that. I'd have to look into that a bit further. But yeah, they definitely have a massive satellite balloon program that's not like hidden. You know, they admit that. And yeah, there's tons of footage of your satellite balloons, you know, being spotted through telescopes and things like that, and also tons of footage of them being launched as well. And there's all different kinds of ones as well.
I hate niggers!
Hey, please refrain from that.
Like, damn that asshole.
Yeah, who was that? Did anyone catch that guy's name?
Yeah, I wasn't looking at the screen at the time, so I missed it.
They left, didn't they? Yeah.
Rude.
I guess they won't last long anyway.
Well, if that was their entire argument, then
Anyone got evidence for the globular model? We truly appreciate all the cordial speakers that have come into the room today. Anybody else have any serious questions or commentary or proof of the globe?
Ah, dang. What's the command to ban here?
I got it.
All right, cool.
Oh, double ban.
Yeah, if anybody's listening, feel free to follow the links and hop on in and share your thoughts with us. It'd be really, really great to hear what you have to say, as long as it's constructive.
Yep, and we also have a home server, right? So if anyone is interested in joining our home server, you can click on Cambo Beats, click on his name, and there's a link right there in the profile. So on the home server, we have about 30,000 members, and we have terabytes of information about Flat Earth, categorized into information channels.
He's right, you know.
You guys have literally sent me down the rabbit hole. I can't believe it. Okay, well, I thought of another question, if that's okay.
Yeah.
Okay. How do you guys explain the tide? I understand that you guys don't deny the fact that the moon exists, right? Everything you can see, you believe in, which is fair.
Yeah.
So,
but exactly what is the moon? We can't validate exactly what it is. I mean, the moon's actually quite a big mystery once you look a bit more into it. Even though it's one of the things we can see more easily in the sky, there's a lot of mystery to it. But yeah, with the tides, we don't really have a good explanation for the tides. But yeah, could absolutely be something to do with the sun and the moon.
Well, I
Could have
got
something to do
for
with
you.
awesome.
Because I've gone into this. Let me see if I have a GIF for it. Yeah. So the tides circle the amphidromic points. The amphidromic points never rise or fall. So regardless of the position of the moon above those points never go up or down. So that destroys the idea that the moon is pulling on the water causing tides. It's simply a correlation because we see a correlation with the tide height and the moon. However, we also see a different thing, which is the pressure systems that move over the Earth also seem to correlate with the tides to some degree. So if you have high pressures and low pressures pressing on top of the surface of the water, naturally you're going to have differences in the height of the water. So that's one aspect of it, but that can't be the complete solution, I think. That's one aspect of it.
If you look at the sheer volume of water that evaporates every single day, it's tremendous. And that's just one factor.
Yeah, that's really interesting, Drace. Definitely stole all of those animations.
The way Drace just explained that was great. That was awesome.
And there's also a bunch of inconsistencies, you know, in the way that they explain how the tides work on the globe side as well.
Yeah, there's certain points at which there's a correlation with the moon, and there's other points where it's not correlated or connected at all. There's also places on the Earth, like Drace kind of spoke about briefly, but there are places on Earth where there are no tides. And the phenomena of the tide is kind of interesting. It is, a raising in the water level twice a day in certain locations, right? So a raising of the water level to be connected to a body that is, a certain distance away from the Earth, supposed to be having some kind of tractor beam, which they call gravity, which is also a complete farce, pulling up on the water, is kind of an absurd notion.
Thanks for joining. If you guys haven't been here before, if you have any questions or any globe evidence you would like to present, feel free to mic up and introduce yourself. That was a good question about the tides,
Yeah, I was just thinking, but you guys have an answer for everything. This is crazy. Okay. Fair enough.
Some of us have been doing this for a very long time.
Yeah.
But feel free to ask whatever questions you want to, man.
There are plenty of questions you could ask where we would just say, I don't know, and we're not going to bother to speculate because there's just certain things that we can't do.
Yep.
Anything that's too...
Go ahead, DJ.
Well, I was just going to say, anything that's too high for us to validate or anything that's too far for us to reach, it falls into the speculation category. We don't usually make very specific claims about things we can't prove. We don't want to do what the globe side does and speculate and, throw out a bunch of claims that we can't back up.
Yeah, I was always very skeptical of somebody who had an answer for anything with no basis behind it, other than a trust me, bro. But you'll see that in the heliocentric model. There's an answer. These guys know what was happening 11 billion years ago, and they'll present it to you as they know it as a matter of fact, with no evidence to support their claims. So it's a slippery slope when you just trust people with no evidence.
This is why we like requiring people to cite their sources. Like, provide us a citation. If you're going to make a claim, you're going to have to prove it. It's a good way to do it.
So take, for instance, your question about the tides. We're not going to make any positive claims as to actually why they occur. We did compare the idea or the story behind why the heliocentrist would say we have tides, and when compared against reality, it is found to be inconsistent, if not patently false. So we can say, well, we tested it, and reality doesn't bear it out. But really, what's going on? Really can't say.
Yeah, we can't claim full causation, just like with the tides. And I was talking about earlier, we know that pressure on top of a liquid can cause different changes. If you have different pressure on the liquid over here, but not over there, you can cause a little bit of change. And all these different factors we do know have some effect. But can we say it's the totality of the effect? No, because we cannot independently verify that by any means. All people can do is assume based on the little information that we do have about how things operate. And that's what they did in the first place with the tides. They assumed, because there was correlation with the moon, that it was caused by the moon, and then they just kept on with that assumption and try to stack onto it because the tides don't match to the moon's motion. Some scientists are like, well, the water must be sloshing around in the ocean basin, and that's what causes the tides. So it's all just theories. Like 99% of the globe model is theory. The rest of the thing is just observation that everybody else sees. You see the Earth is flat, you see the sky above you, and then you just assume everything else.
I will tell you guys that I have immense respect for the fact that you guys don't speculate. That's really good.
Yeah, it's fun to speculate, but I mean, if we're going to speculate about something, we'll be very, very sure to mention that it's just pure speculation.
We do actually once a week, we have a speculation thing on Sunday, Speculation Sunday, where folks are more inclined to talk about their speculations. The rest of the week, we stick with the subject here, for the most part.
But that also allows us to, you present your idea, you speculate about something, and then everybody else goes like, wait, but what about this? But what about that?
Yep.
And then you realize, oh wait, yeah, that was wrong. Now I understand this better than I did before. So it's a learning experience.
And it helps strengthen arguments. Keep the good, throw out the bad, eat the meat, spit out the bones.
Yeah, when it comes to the question of why would they lie, you enter the realm of speculation. But there's a lot of good reasons that come from that, right? But none of it can be verified unless you're actually having an open dialogue with the ones who are propagating the lie, right? So that would require them admitting that they're lying. So that's a tall order.
What's funny is you could just link an article, like a generic "Why do people lie?" article to folks, and that would answer any question they could possibly think of. It's across the board. That's why people lie, for those specific reasons. But to ask why would they lie is very specific, pointed, and usually with the intention of trying to debunk anybody claiming that there was dishonesty. Meanwhile, we've got a ton of NASA bloopers, and they are hilarious.
Oh my goodness. Well, I mean, if what you guys are saying is true, right? This goes beyond a lie. This is like mass delirium. This is stuff they've been feeding people for generations.
There's religious connections to it, man, so it ends up getting passed down. It goes back to the cult of Pythagoras and even before that.
Ugh.
So, how are my favorite flat earthers doing?
Doing well, thank you, Tommy. Welcome.
Yeah, thank you for welcoming me.
How are you doing today?
I'm good. I'm just interested. I want to get knowledge. I want to understand how I've been lied to all these years.
Fair enough. But if somebody's told something, they honestly believe it, and then they repeat it to you as though it's the truth, are they actually lying, or are they just deceived?
They're deceived, just like me.
Yeah. So most people aren't liars. They're not actively going out of their way to try and tell you some fairy tale story. They were given that story, and they're passing it on to you like it's a treasure, like it's important and you must know this. They don't know that it's wrong.
Yeah, but that's why we have people like you to enlighten us, so we can.
I'm no teacher.
So the people that like me that want to get to the truth. That's why we're here.
If you seek the truth, though, you and I are not that different, because that's kind of the entire goal. You just autodidactism. Once you learn how to teach yourself, you don't ever have to stop learning. You can do that for the rest of your days, and it's awesome.
Yes, sir.
Mostly that's what we really want people to do, is learn about critical thinking and what fallacious reasoning is, and just do better. We're not trying to push our worldview on anybody. It's just, hey, here's some information. What do you think about that? Let you decide. Don't take anybody's word for anything either. Fact check everyone.
So the first question would be, why have they decided to lie to us in the first place? I'm talking about the NASA, the government, everything related to this big lie.
I don't think that's the first question. The first question would be, how does the Earth measure?
He's right, you know.
I guess we have to find out if anybody was lying in the first place.
Yep.
Yeah, this was something that started quite a long time ago. So, I mean, proving why someone would lie is very difficult, but we can prove that they did lie and that the Earth isn't a globe.
Yep. It's kind of like if you walked into on a murder scene, you see a body there. You don't have to go and hunt down whoever killed that person to know that there was a murder. You know somebody's dead. I don't need to know who killed that person. They're dead. They're gone. And for the same reason, I don't need to know why somebody lied or who did what when it comes to this. I just know that the official narrative is wrong.
Yeah, just like you don't need to know why the person killed that person.
Yeah, I don't need motive. I just know what is. If it is, then it is. If it ain't, it ain't.
Yeah, I mean, obviously it would be nice to know motive, to be able to prove motive, but that's not always the case. But we could definitely prove that there was a lie that took place. And when it comes to who's lying, like NASA, the government, right? Most these are just huge organizations that have tons of people working for them, where most people would have no idea, right? Like most people believe that the Earth's a globe genuinely, and many of these people are working for the government or for NASA, which is basically the government at the end of the day. NASA.gov, you know.
So they're very much compartmentalized.
Exactly. So you've got people that, you know, they have a non-disclosure agreement, and then they have their job on a need-to-know basis, and they don't know what the people in the room next to them are doing, and so on and so forth. So it's not that many people. It's very difficult to write a list of who is lying, like who knows that the Earth is flat and they're lying about it being a globe, right? It's like very hard to make a list and then be able to prove the people on the list are actually lying. Would have to only be a small amount of people that would have to be in on it. And who really rules the world, right? You know, there's
people lie to themselves too. Like the ideomotor effect, where you can have subtle muscle changes based off of your perspective, what you're thinking about, your worldview can affect an experiment and the outcome. And somebody could have bias without actually knowing it and ruin an experiment by simply interacting with it. It's driven by confirmation bias.
Yeah, but I mean, there's a question that naturally arises out of all the flat Earth theory, and is if they're lying about something like this, then what else are we being lied to about?
Yeah, it's true.
You know what
if you think the fake news is bad,
the tip of the iceberg. If you look at it,
have you seen the Sinclair script? Like there's videos on YouTube about it. It's called the Sinclair script, where all these newscasters are just repeating the same exact thing. It sounds really creepy when you
that's the creepiest thing.
Yeah, I watched it.
That?
Yeah, it's crazy. It's just like very scary.
Yeah, it's disturbing, and it's definitely a form of mind control. Mockingbird.
Yeah. So that gentleman brought up an interesting claim. You know, what else are they lying to us about? That I can verifiably tell you. They're lying about almost everything. They lie on the regular. This is not even...
Yeah. What are they telling the truth about? Is a better question, probably.
Exactly. And when you see like how bad the fake news type stuff is, imagine how bad history is.
Dude, I just lied. Oh my god.
It's written by the victors, and almost all of them lied.
So wait, are you guys having discussions about flat Earth?
Flat Earth
yes, we are.
But we can get back on topic.
Yeah. Sure.
Oh, okay. No. I was just kind of wondering. I didn't.
Do you have any questions?
I guess I do. I mean, like, is anyone in here like flat Earth, like believer or something?
I wouldn't call it a belief.
Yeah, there's tons of flat Earthers in here, and globe Earthers in here at the moment.
Okay. I just want to ask, like, were you a flat Earther or something?
Well, Yankee, would you consider the measurement of your height to be a belief or knowledge?
Knowledge.
For the same, that's exactly the reason why I wouldn't consider this a belief. The horizon remains horizontal. That's knowledge. It's an observation.
Yeah. So, like, I'll ask you guys a question. It's like with my own thing. If I see like, if I'm like 40, how tall do you think the Earth is?
Tall.
The horizon. How tall do you think the atmosphere is? Like
wide.
No, the sky. The sky. So like, how tall?
Oh, no idea. There's no way to test that. We can only get up to a certain height. We can only send weather balloons up to a certain height as well, about 120,000 feet.
Okay. So
then you would see the balloons like getting like very high, and you start seeing the curvature of the Earth. So how would you guys? Yes.
No, if we send a weather balloon up with a rectilinear lens, which is a type of lens that doesn't distort lines, like a GoPro lens or something like that, right? They distort straight lines. So yeah, when we send up a weather balloon without a fisheye lens on it or without a wide angle lens, it's completely flat from that height. Probably got some clips here we can chuck in the side chat, actually. I'm sure someone will pop some in there. But that doesn't necessarily prove the Earth isn't a globe, right? So, even mainstream scientists like Neil deGrasse Tyson, right? He's gone out and done shows where he says that from the height of the Red Bull jump, which was 129,000 feet, he said you wouldn't see any curvature from that height anyway.
Well, it would look inverse. That's what he said. It would look inverse.
No, he said from that height. This is what he said word for word, and I'm going to put the clip up as well, right? He said from that height you don't see the curvature of the Earth. That stuff is flat. That's what he said word for word. And on top of that, right, they went to a higher height than that, right? So they had the Virgin Galactic flight that went up to 300,000 feet, right? So more than double. Or just a bit less than double, actually. Anyway, then we had the Blue Origin that went up to 350,000 feet. So Neil deGrasse Tyson came out after both of those happened. And once again, he said they're very deceptive in the way they portray the footage using the wide-angle lenses, and that he did the calculations and he doesn't think that you'd be able to see the curvature from even 350,000 feet up. So...
Well, like...
that stuff is flat.
Okay. So if I were to say, like, I was 40,000 feet up in the air, on an airplane, and I saw the curvature of the Earth, what would you say that is?
Well, not necessarily. I mean, yeah, it's not the curvature of the Earth, but, planes have very thick round glass windows, like triple layered glass. So, I mean, you're looking through like a spherical thick glass lens to begin with. I mean, I fly a lot. I mean, I've never seen any signs of curvature. The only time I would see
before.
But also, you got to remember this. You got to remember this as well. Like, you see in a circle. So if you have a large field of view and you pan your eyes like right to left, you can see the same distance in all directions. So you kind of see in a circle of vision at the same time. So someone that thought the Earth was a globe, right, might think that they're seeing the curvature of the Earth when really they're seeing in like in a circular fashion, right? Like, here's an example. If you went out into the ocean and you're on a boat, right, and there's nothing else around you, just ocean, the furthest distance you can see all the way around you, right? If you plot that out, it's just going to make a big circle. So you go up in altitude, you can still see in a big circle, right? Just to see the same distance in all directions. So someone could definitely mistake that as being the curvature of the Earth, I guess. And also you got the window to take into consideration. But I mean, I don't know. I've flown like super long flights quite often, and I've never seen any curvature, but maybe some windows are different. I don't know.
Yeah, I have seen a slight distortion at the edge of the window, like I posted in at least in some of the airplanes I've been on. And if you go in the chat, you can see it. I posted it. And then there's also the lemon illusion, where straight lines can appear curved, especially when you have this kind of small bending at the edges due to the curved glass. You end up seeing a curve where there isn't a curve. There's also wishful seeing, which is if you believe really strongly that you should be able to see a curve from an airplane because you've heard that you should be able to see a curve from an airplane and you believe that you're on a globe, then just like a hypnotist can make you see the apple or the onion as an apple, and you can bite into the apple and it tastes like an apple, your belief can be strong enough to impact your visual or your memories after the fact. So I would highly recommend that now that you've been exposed to this, you go, next time you go on the airplane, look at the horizon, not near the edges of the window. You can also look through the window when you're on the tarmac, and you can see the slight distortions near the edges sometimes. And but look at the center of it, and you can take something flat and put it up against the window and see that the horizon is flat. It's not going to start curving at that height. And if it did, then the Earth would be so small that you wouldn't be able to fit America on it.
Well, again, what I'd say is this is like, I did not, when I observed the horizon, okay, I was not looking at it was not near like the edges of the glass, okay, it was actually in the center of like my view. And another thing was I was not expecting it. At this time I had like clear skies, and to be fair, like for the most part, I don't really see this. But I think in this special case it was because we were high enough and the sky was clear enough, which isn't the case most of the time when we're flying, that I was able to see the horizon. And I wasn't expecting it, and I thought this was like a really cool thing to see. being like the curved horizon. But again,
that
just
doesn't
because
work,
I start,
bro. It doesn't
because I
work.
see, like,
Mathematically, the horizon couldn't be curved at that height.
again, even okay, just because you start seeing the
Unless you're
beginning of the
claiming the
curve.
ball is so tiny that, like, all of
No.
Europe, Africa, like Australia, Japan, that those things don't exist to you? Like South America doesn't exist?
I never said that.
Well, if the ball is so small that you're seeing it curve from an airplane window, then that is how small it
I'm
is.
saying you can get high to a point where you start seeing curvature. It doesn't mean that
Well,
I
you
get
shouldn't be able to see the curvature from that height in the horizon, because the horizon is, first of all, an optical phenomenon, not a geometric phenomenon.
Oh my gosh. Okay. What? So, why do you say like the Earth is flat? I mean, I think that's like the biggest thing I'd have to ask.
Because the surface measures flat, is used as flat. There's no evidence of it being a curved surface, or there's no evidence of it being rotating. So why would I believe it's a globe when there's no evidence for it? When we
Have you seen like
experience it as
Euler's
flat.
formula? Have you seen Euler's formula for the for solving like the specific problem? I could probably show it to you. Where pi was used inside of his argument.
What does the formula have to do with anything?
Well, essentially what I was trying to get at is like they were trying to solve a specific formula about how much light could you see from a lighthouse, like from a specific point if it goes X distance far away. And what Euler figured out is like it doesn't go infinitely on as people say it does. It actually goes in a circle. But if you zoom in enough, it appears as if it's a flat line. And so that's what I'm trying to get at with you is like something can be so big that if to your natural eyes it appears to be like flat. And another thing is this is like
No, that's incoherent. First of all, we're using lasers and other things to measure it. We're using infrared cameras. We're seeing far beyond what should be geometrically possible, over 10 times beyond the geometric horizon. And the only excuse the globers have is, well, the light must be bending around the globe, making it measure and appear flat at all times. And so what we do is we take the infrared camera, we look through the infrared camera, and if light is refracting around the ball to make it appear flat and measure flat, then, because infrared refracts less than visible light, then we should be able to see the horizon move closer in infrared. However, what actually happens in reality is that when you look in the infrared, you see even further. That's why all world record long-distance photographs are taken in infrared, because the globe doesn't exist.
That doesn't make sense.
What doesn't make sense?
The fact that you
what's the drop over distance for a sphere at the claimed radius?
Yeah, this is like undeniable, mathematics based off what we're given by the globe side, based off the radius value.
Yeah, literally your entire cosmos was conceived based off the radius value. Did you know that? It's the beginning of your cosmic ladder.
Okay. So what about this is important?
Well, the radius value, when we go out and test reality, right, for the characteristics that must be present for this radius value to be correct, right, we can see magnitudes further, right? There's no validation of the radius, right? It just exists on paper, in theory, not in reality. Like we can see, for example, if we go to a 20-mile lake, it should have just under 300 foot of curvature. But we can zoom in across the surface of the water and see the shoreline on the other side of the lake. There is zero curvature. Then we can go do it on a different lake, in a different lake, in a bigger lake, and this has been done over and over again and documented. And it's not just the observations. There's many more methods that are being used. The list goes on and on and on with the evidence against the globe.
So what would you say about ships disappearing across the horizon?
Growing up on the east coast of Australia, in a section called the Gold Coast, right? Tons of cruise ships, tons of fishing boats always going out, right? I grew up at the beach quite often, fishing, surfing, boating, and watching the boats going out while I'm sitting there waiting for waves or whatever, right? You're sitting there kind of watching the boats go out. What happens most of the time, right? The majority of the time is the boat will just get smaller and smaller, and then eventually you'll see it start to disappear because you can't resolve it once it gets below a certain angular size, or it'll just kind of fade off into the opacity of
It doesn't fade off. It doesn't fade off.
No, it does, right?
Yeah, no, what it does is that at first the hull disappears to begin with.
No, that depends on the conditions, my friend. No, my friend.
Yeah, let me finish
it depends on the
explaining.
conditions. Let him finish, and we'll go over that in the end.
Yeah, I was going to go over that as well. So just what happens most of the time, I said most of the time, right, is that it just disappears due to angular size, right? So you can't see the boat anymore, but you can still see the horizon. Now, what we've realized is we can zoom back in and bring the entire boat back to view, unless there are certain conditions present. Now, sometimes you can have ocean swells. It's very common. So as you have like the waves in the foreground, right? And as the boat goes further away, the boat gets smaller and smaller, and it disappears behind the big waves in the foreground, right? So even if they're not huge waves in the foreground, it's kind of like the concept of how you could kind of put half your hand in front of your eyes and block a mountain, or block the bottom of a mountain in the background, just on a different scale. So, that's one of the main reasons that it can make it appear like they disappear bottom up sometimes. And then there's also certain weather conditions where you can have certain types of miraging type effects, like sinking, for example, where, it's defined as something that would normally be visible on the horizon, looks like it sinks below the horizon. So sometimes that happens as well.
There's also some compression effects that, depending on where they happen, if they happen at the bottom of what you're looking at, they can compress the bottom down until it becomes too small to discern, so you lose that bottom information.
Okay.
Yankee Zulu, do you see the side chat?
No, I do not. I actually don't.
Have a look in the side chat. Yeah, there's a ton of supporting GIFs and things like that people have been posting. So especially like the one that Miguel posted at 28 minutes after the hour. It's like a giant ship, right? And when he's zoomed out with the camera, you can't see the ship at all. But when he zooms in, you can see it again. That's what happens, most of the time when you have clear weather conditions. But sometimes it does appear to fade off, like just fade out, right? Because sometimes you don't have a long visibility rating. You can check the weather report. Sometimes the visibility is only, 5 miles, 10 miles because of fog and things like that. Or just a lot of dust and things like that in the air sometimes.
Okay. I mean, there is a possibility from that, but I still, for the most part, when a ship is disappearing off the horizon, and again, I don't think this is the best argument for it, for a global Earth. I mean, dude, you still have Arastani's method, that argued, from, the specific shadows of the stick that it laid.
Yeah, we understand. Aristophanes had shadows. He looked at the shadows and assumed the Earth was a ball. And yes, that's how that starts.
He already assumed it was a ball.
Yeah, that's how you started. You assume it's a ball, and then the shadows land differently on that ball based on the light being all parallel. If the light is all parallel, then the shadows would land like X, the shadows land like X, therefore the Earth is a ball. So begging the question of circular reasoning. However, the Chinese also did the same thing. They also begged the question and used circular reasoning to affirm their cosmology, which was flat Earth. And so they used the same sticks and shadows from the sun, and they used light splaying out from the sun. So when you look at the sun and you look at shadows from the sun, you see the shadows splaying outwards because the sun is a point in the sky where the light is coming from your position. However, that works perfectly for a flat Earth and gives you the exact same shadows. So you gotta either think, is the sun a gigantic ball that should fill your entire sky, shining parallel light rays all the way down, but it's so far away that it shrinks down into this tiny point, which is just like you have no evidence for any of this? Or is it just as you perceive it and how the shadows show it to be?
That does not follow. I'm sorry, but I didn't really follow what you were saying.
Do you know what the Rayleigh criterion is?
Raleigh or Rayleigh?
Rayleigh, but it has to do with the limitations of an oculus, the aperture of either your eye or any type of camera lens.
Okay.
There's limitations to it.
Okay.
Well, let's just quickly, hold on. We want him to understand the Eratosthenes thing quickly, right?
Yeah,
so
let's finish that. Sorry.
It's not something that's exclusive to a globe. It just depends on the assumptions that are made. Now, you could do the same thing, in a room in your house, right? You could have a stick under the light in the center of the room, right? It's not going to have a shadow. And then you can put another stick towards the edge of the room and it's going to have a shadow. Now, if you went ahead and made the same assumptions that Eratosthenes made, and you assumed that you were on a spherical floor, right, a curving floor, and you assumed that those sun rays from the light on the ceiling were coming in parallel instead of diverging, then you could do the same math that Eratosthenes did, and you would be able to calculate the circumference of your flat floor, right? Just based on the assumptions that you made. It's even globe Earth scientists, physicists, and people like that have made videos explaining how it doesn't really prove anything because of the assumptions. It was only because of the assumptions. that he was able to use his spherical mathematics, right? Because he did, he did his maths based on a 360-degree object, the globe that he thought that he was living on. So, I mean, it's not something that, it's not like a flat Earth proof or a globe Earth proof. It's just, it's a flawed test.
Well,
that's all.
Aristophanes was not trying to argue for, he was not trying to argue for global Earth. He was trying to argue, he made the assumption that the Earth was round, but I think the fact that
he was trying to work out the size.
Yes, that's what he was trying to do. It's what I was gonna go on.
Well, that's what he was.
Sorry, go ahead.
Yeah, he was just trying to work out the size, but it was just based on his assumptions that, the Earth was a globe and that the sun was an infinite distance away with parallel sun rays. So it's just big, if you take away those assumptions that he made, the same thing works just fine on a flat Earth with a closer sun with diverging rays coming out of it in all directions. So,
he was trying to affirm the globe because based on how big you assume your ball is in the beginning, that changes everything. Okay, so he already had the presumed size in the beginning.
No. Well, the actual circumference of the Earth that he actually had come up with was actually according to modern scientists, was considered almost accurate to.
I know he had the same thing. Okay, they actually derived. This dovetails perfectly into what Rayleigh was talking about. They derived the size of the globe from the diffraction limit of the human eye. So we can calculate based on the diffraction limit of the human eye and how far away the horizon is, the optical horizon that appears in your eye due to perspective and how your eyes work, optics. And so we can calculate, based on the diffraction limit of the human eye, how far away the horizon would appear. And that turns out to be about 3 miles away for a 6-foot observer. That's exactly the same size as the globe, and that's the exact same thing they used to derive the globe with Al-Biruni. And so all of it is just looking at the horizon, not understanding optics, and then assuming a globe. And from there, they got the size, which Aristophanes tried to reify. And this is not, they don't even know if Aristophanes existed, because there's no actual prime first source material left that has him. He's referenced in 2 manuscripts. That's all. And from there, they base everything. So it's bro, he needed the size to begin with. If you blow up the ball to be the size of the sun, the distance between Cyane and Alexandria is so small that it's effectively a flat surface.
And then how come there could be different shadows? Unless you're going to say
I want to add this at night. You can see the same shadows with the moon. Interesting.
Yeah, because
that's a good point.
The moon is coming down at a direct, the light is coming down at a direct angle, and so
that doesn't work because the moon is not 93 million miles away. The light from the moon is not supposed to be parallel like the sun.
And so you're saying the moon is coming in at an angle?
The light from the moon it's like the light from the sun. It's divergent. It's not parallel.
Yeah, we only experience the sunlight coming down as divergent rays.
I can post. Let's see.
Yeah. If someone can post some things, that'd be good.
Let me see divergent rays like these ones.
Appreciate you guys coming in asking super good faith questions and having a polite discussion. Sometimes people come in super angry and rude and don't listen to any answers, so appreciate that.
Yeah, this I did actually there was a day it was raining, but then it stopped it, and there's some clouds passing by, and I could see this divergent rays, and it was a hole in the middle. I took this photo. I think I did burn the lens of the camera of my cell phone because it was too hot. And I have another one. I don't know if you can see it. You have to click it. But there was a time, I was farther away and I could see the further away. I could see that it was raining, and then I could see these clouds, and above. So I was watching those crepuscular rays, So I could see the clouds was very low, So I could see it was going direct to the sun that was above the clouds. So I could see, I didn't took the picture, but it was very interesting, The angles was crossing these clouds and going up until the sun. So very interesting. And actually, one day I was watching anti-crepuscular rays. So at my front, at the west, I was watching this crepuscular rays, and then at my back, they were converging into this, the vanishing point at the horizon. So that when I saw that, I was like, "What is happening?" But then when when I was thinking, so it is perspective, exactly. And from that same location, I could see many airplanes passing over me. For example, coming from north to south, and they appear like going in an angle, going up, like I don't know, maybe 35 or more. This angle, it's apparent. It's from my point of view. So this airplane was passing over me. So it was appearing, going up, 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 and then it passes over me, and it appears going down, down, down. So that's perspective, I saw, for example, at west. So I'm from Portugal, so sometimes there's these airplanes going from many directions, coming from Spain. So I saw one day, for example, looking at the horizon, above the horizon, an airplane passing by, and he was leaving a straight, let's say, chemtrail or contrail. So it was horizontal, parallel with the horizon. So that was very interesting.
I don't know, Toby. Do we have any other Globers here? There's still a couple.
By the way, I just realized that the only reason they think light is parallel is because they believe the Earth is a globe. And so when they see the light move in the sky, move across the sky, that entire time the light is in the sky, the light is always parallel to them, even though the angle is always changing, and it clearly is not parallel relative to your location. It's just parallel in their imagination on the ball.
Yeah. This Aristotle's fairy tale story, I don't know how they talk about this without even knowing the basics. He did assume the sun rays was coming parallel, and he did assume that it was already a ball. So
yeah, man, I guess it's one of the first thing that comes up on Google.
of course, you have to have this at the same time in the mind, because when they hear, let's say when these Globers they hear about flat Earth, they try to figure out in their mind, but they cannot figure out because they don't know it. So as we know, so that's so to them it appears that it's ridiculous, at the first sight. But for example, I saw a guy, this how you say He's a known guy here in Portugal, speaks on TV, etc. But he did an article, a web page, trying to debunk flat Earth, and the guy just, what he did, the guy just went to Google and searched it. He thinks that he's gonna figure out what is flat Earth by searching Google. And he did post some memes, a flat disk in space, those propaganda bullshit, and so the guy doesn't know what is flat Earth. He just did a search at Google, find some stuff, and he did this article, but it's a crap. But 500 years ago, it was normal. These navigators, they were flat Earth navigators, and they were navigating the oceans according to flat Earth. But when people hear about Magellan, Ferdinand of Magellan, his original name is Fernando Magalhães, Portuguese name. So they read in these textbooks, this story, Magellan did found the Earth is round, so you can go around, in a circle, like a circle. You can go around something. That's circumnavigation. And they think, but I never saw a text from him claiming it was round like a sphere. So we have and the guy didn't finish the journey, So we have a big problem there, People are making claims about that guy, round like a sphere, but I never saw a text of him speaking about it. So, at that time, we have a Portuguese flat Earth. The first time I hear about flat Earth was actually on Portuguese public school, flat Earth. So at that time, we have this, Portuguese and Spanish navigators, doing discoveries in the oceans, and they were doing to them it was flat Earth, it was normal. But then of course that Magellan already did stolen some maps from the Portuguese. He was a Portuguese. He did learn how to navigate here in Portugal, but at that time he had no job. So he went to work to Spain, our rivals, main rivals at that time. He already had maps, to where to go. But of course he had to figure out because at that time there were no complete maps. Sometimes they have some coastline, and it was incomplete. But the guys just figured out another way to go to India because the Spanish, they want badly the same spices that the Portuguese were making trades. So yeah, the guy just figured out another way to go around. Nothing new. I can go around an island. So after that, after that time, there was some kind of meeting, and at that time we had the power of the authority of the church, and some authority from UK, and that's, for example, Mercator, the guy were drawing maps. He was drawing a different North Pole from today, what they present to us. So what's going on? Yeah, why would they lie? Why they hide that? Yeah, ask to them because I was not there. But I did found some names, Portuguese and Spanish. So from the 1600s until the 1700s, there were people even connected to the church, and they were against these new scientists. At that time they called new scientists, between quotes Isaac Newton and whatever. Because they were saying even counting the Bible because they were Christians. In the Bible it doesn't say it's a sphere. So, but anyway, and even I did found some texts. They were talking about it. Maybe the moon has its own light. So it was when from the 1600s until the 1700s we have flat earthers. Question about this ball earth. Someone decided to change it to a ball earth. Actually, I was remember there was a pilot. I don't think it was a commercial air pilot, but a small aircraft. So it was a pilot and let's say a shooter. So he had his credentials, and one day he was flying, and suddenly his gyroscope did fail, and the guy just fly straight a long time. So and it was like at that time, how can this be possible? Because I'm flying straight, if there was a ball, it should be I had to the nose of the airplane, the aircraft. I had to pitch down, and he never did that. So at that time he was thinking about that. Yeah, no, he's a flat earth. So, and he did talk about Coriolis. He never, as a pilot, he never learned about Coriolis to count any Coriolis. 0 hours. And in shooting, he did not account Coriolis either. There are some tables. He was accounting more, because of the bullet coming from the barrel, it spins the bullet. So he was talking about the Magnus effect. So that was very interesting. And we have a lot of people from Brazil, not from Brazil, but most, many countries, independent people, even civil engineers and wherever, surveyors, you name it. They were Globers. They went to the field, to figure out if there was curvature on water, even on big lakes, even using lasers at night, and even doing a surprise with a flashlight next to a laser. The other team was, at the shoreline, and they were saying, "Oh, I see the laser light, and I see another light." So it was a surprise. This was at the water level, the flashlight. Anyway, and they figured out there's no curve. It's impossible. No curve, no ball. And they were Globers. But at the same time, we have people that they cannot speak because if they speak, they can lose their job. But sometimes we have this luck, some whistleblowers, even from NASA, pilots, commercial air pilots, But some of them did speak about it, and they lost their careers. Some of them they talk anonymous, Thank you, John Luna. Well, it's about the truth, nothing more. I prefer, sometimes, they ask, why would they lie? And then, white matters, white matters, and then, if it doesn't matter, to know, the truth of the lie. So it's up to them, if they want to think whatever, in their imagination, they can live with that. But I prefer to know the truth and live the truth. I don't care about fairy tales, fantasies.
I have another question, if that's okay.
Ask.
Okay. There was a gentleman in here earlier. I was just watching it on the live stream, but the topic of divergent light was brought up, right? And how the moon, if it's being hit by divergent rays of the sun, it wouldn't show up as it is, right? Because we see like a certain luminous property from the moon itself, right?
If you let's say if you do let's say optical thing with divergent rays going in, reflecting on some kind of surface, you'll get a different result.
Yeah, my question would be, do we know how divergent rays act in a vacuum? Because the whole global claim is that the moon is in space, and space is sort of like a semi-vacuum.
There's a problem. You say semi-vacuum, and you learn it's a vacuum, the vacuum of space. There's a problem.
Yeah, I know.
We don't observe.
I know how the claim is not.
Here on Earth, you don't observe. Vacuums are not a natural phenomena. But when you talk, I can even post this citation. It's a simple citation. What is gas pressure from NASA? Let me see, just a second, from NASA. But what is interesting, it's you can learn this in physics. But let me see, just a second. But what is interesting, when we speak about gas pressure, and go look at the definition, what is gas pressure? It says the gas particles are colliding with each other and against the walls of the container. So, no container, no pressure. So and I can post this. It talks about the container. It's not for me. But we have people that don't want to accept this. They ask, show me the container. But the problem is that to have gas pressure, you need a container. Of course, inside the container, you can have. I can post a guy who did an experiment, with a container, different gradient, So even if you watch the Weather Channel, they talk about high pressure and low pressure, So where there's zones that there's this warm air and it rises up, and at the same time it's bringing cold air. So sometimes if you search how wind happens, it talks about high pressure and low pressure. Yeah, we can have a gradient, let's say low pressure and high, but if you do this experiment and you have a gas and you put a vacuum, in other let's say chamber, you have one chamber and then you have with the gas, and you have another chamber with it's a vacuum, and when you open in the middle, they mix, and that debunks this ball air in space, with this atmosphere around next to a vacuum. It debunks it. They can talk about this fairy tale. There's some kind of gravity. I never at school. I never hear about this gravity holding gas pressure, because where is that experiment to prove that? You can say, oh, this magic glue Narnia stuff is holding gas pressure, but where is that experiment? So that's a big problem right there. And actually, so I saw a video. It's in Spanish. The guy did spend like 1 hour and a half talking about the cold energy, circuit from Tesla. And but at the beginning, the guy he did say, I did spend 1 month in the house of an astronaut, and he did said to me, this astronaut, of course, he didn't want to say his name, so I don't know who is the guy. But anyway, he did say, this astronaut did say to him, from above you don't see Earth as a ball. That's very interesting from an astronaut. And then he did say, there's a barrier. No rockets went out. So very interesting too. So there's a barrier. And I did, 25 years ago, I did met a physicist guy, And the guy did speak about it, he didn't say flat Earth, but he was, there's people question about the shape of the Earth, there's people question about the moon landings being fake, and the guy said was a physics guy, and he did said, that they did found the barrier, but he did stop it, because I wanted to know more, but at that time I was a global and I was not connecting all the dots, but I was interesting, but he did stop it, because he was getting too much attention, and he did suffer before he did tell us something that did happen to him when he was at Brazil. Guys from, let's say, guys between quotes from America did went to this guy to meet with this guy, to not speak about some stuff. I'm not talking about related to flat Earth, but it was another stuff I don't want to talk it. So they did threaten this guy. So maybe that's when he was talking about the barrier, he didn't want to speak more because he was getting some attention. Yeah. So, but this was 25 years ago, and. Now we have this, let's say, globalists saying, oh, you can have a gas pressure without a container. Yeah, very interesting. But And we have ex-airspace engineers. I can give you some names, from NASA, speaking about flat Earth. Even a guy that did programmation to satellites, at Antarctica. Interesting. But in his papers, it was it was writing there. You have to account a flat stationary Earth. Very interesting. There, even military papers, not just military, but even NASA is speaking about it. It was more efficient. For example, there's some paper they say it's more efficient flat Earth model accounting for satellites instead of a global Earth model. And there's papers where they say you have to account flight dynamics. You have to account a flat non-rotation Earth. So this is where classified documents. There was a law at the year 2000. So from time to time they have to release some info. So this is where classified documents. Because of what? Formulas? No, there are sensitive information that's classified. When it's classified, it has sensitive information. So yeah, it's very interesting. Even there's a document talking about the Russians. The Russians, 1952 and 3, something like that. The Russians were at Antarctica, and there's one page that they are talking near sun, flat Earth, and firmament in one page. Anyway, and that was classified, and it's on the CIA website. I did listen. This guy, he was a global. He went to talk to. He was a helicopter pilot. He did work at Antarctica, and there was an interview they did with him first. So these guys were from different countries, and he was speaking about. In my interview, they did ask this question: what is the shape of the Earth? Why they have to ask this question? It's very suspicious, But he was like, why they are asking me this? Of course, he was a global. He did said it's a ball, But he did, many things he did realize that doesn't work on that globe. So, he's a flat earther. I can show you a live stream talking about flat earth. But yeah, it's very interesting. Why they have to ask this question? Because they don't want the information. They don't want flat earthers there, But it was, let me see if I remember some info. Anyway, it was a long time ago. So, there's a, let's say, there's a backstage, People at the backstage, they don't have this fight between, what if there is a ball or a flat, So they're not in this because they are there doing secret things, away from the public, and that's it. We have no. Sometimes there's some info, but we have no idea what's going on. It's a big deal going on there. He did ask, can I speak some stuff, and the general there, he did say, you can speak, there are some classified things, you cannot speak about it, and who is behind this, but it's not difficult to figure out. Anyway, there's even Rockefeller Hills, something like that at Antarctica, anyway. But anyway, the guy did say, you can speak about other stuff, no one will believe you. And the guy did, speak about it, it's just an interview, and yeah, and then he was speaking a lot. So they did get a plane to get him, and to get a military base. So he's a retired guy, but at this time, they did ask, they were angry with this guy, because of the things he did speak about it. So but they did threaten him, they didn't take risks because he has some connections. But anyway, these guys did invite him to work again with them again, but this time to do the information. So you see, so they did invite this guy that figured out the truth, to work with them to lie. Of course, the guy declined it, but maybe there's some, let's say, a few guys, that you have seen they did change sites suddenly from some kind of reason. Maybe they did threaten those guys, or they are receiving money. Because I did advise, be careful if you see suddenly some flat earthers changing sites. And at Brazil, it did happen. There was a flat earth guy from Brazil, and the guy suddenly did change sites. And but he never went to Antarctica. He did collect some money to go to Arctic, to see the 24 hour sun at the Arctic. So north, and the guy. After that, the guy suddenly did change sides, and he did separate from his wife. His ex-wife is a flat earther. She doesn't know what. There's an interview, it is in Brazil, Portuguese. So, but she did speak about it. She's a flat earther. She doesn't understand why his ex-husband did change sides. So it was very strange. So yeah, things happen like that, The final experiment, I call it from the beginning, the final joke. It's a joke to me, not proving anything. And with it in this time lapse, people did saw some stuff there, and the guy just went there to edit the video and blur it, and he never did said why he did blur it. Why this guy what is this guy hiding? Yeah, very interesting, suspicious. But let's wait, because there are some people that maybe even this year or next year we have some surprises. Anyway, let's wait. It doesn't prove anything. Even the sun, if the sun was doing an 8 in the sky, it doesn't prove the ground. It says, what matters looking at the sky? At TV, on television, you just see CGI animation documentaries talking about space. It's all based on assumptions. They are making assumptions, and that's it. You see just animation, CGI animation. The space that you see there, it's just CGI animation, nothing more. And I did believe that, The Suez Canal, for example, Suez Canal, from the English, there's an article even, it was published after, so from the English side, those guys were saying it was impossible to construct the Suez Canal because you have to count some curvature of Earth. And from the French side, the engineer de Lesseps, the guy didn't account any curvature. He did construct according to flat Earth. And there was an article talking about it, and they even did some kind of law, to construct bridges and etc., railways. And it was, it was hidden. I can put citation from that newspaper. Let me see. Okay. The things I speak, I have stuff at my background, so sometimes at Sundays you can hear some some people doing some speculation, but when I speak this guy or that, I have videos, I have stuff, So let's see, Suez Canal. Citation. So this is that article from 1951. It's still available from website gov.au, Australia. It's there. You click it, the entire article is there, and even selected.
I was going to say welcome to whoever joined.
Are the developers falling down? It's the Skyfall, no curve, no ball. I can make some lyrics improvising. Kimbo Bits, take some notes. Your next song, use it. At 2015, I think, in that year, we had at Brazil, just at Brazil, there was 11 million people, flat earthers. I don't know how they did get that number, but today it's more bigger. But anyway, it doesn't matter. I saw the guy speaks, speaks Portuguese with Brazilian accent, and I saw a live stream. The guy he was speaking. He was at Japan, living at Japan. He's a Japanese guy. So we have a lot of different people living in different countries talking about that. But it's some of them they don't do live streams. Yesterday I did meet another guy, a Brazilian guy, and he did ask me, what is your first language? And I said Portuguese, and the guy did start talking Portuguese. And he's in this like 5 years ago. I did the fishy check-in. When I did talk to about Donato, he's in our main server, he's a silver guy. He was there before me. He did talk about some live streams. He did watch it. So yeah. So every day there's people joining. Some Portuguese, they did join it too. Yeah, that's a good one too. Je ne me sais. From the 1900s.